Okay, so let's review real quick color addition for primary and secondary colors. So in the first scenario, I am going to start with red light, and I hope you remember that red light is primary. So we have red, green, and blue are our primary colors, and yellow, magenta, and cyan are our secondary colors. So if I have red light, I want to shine it on all the possible different colors of objects. So let's say I have paper. So I know that I have red, green, and blue as my primary choices as paper. And then I can have yellow, magenta, and cyan, and we can't leave out black and white. Okay, so the first piece of information that I want you to put is what is the incident light, or what light is hitting our object. So for all of these, it's all going to be red light, but I want you to show me that you understand, because it won't always be just one form of light. So red is hitting our objects. You get 1 point for just putting this in. Okay, the second piece of information that I want, is for you to show me the wavelength that's reflected. This isn't always going to equal the color. So here, a red object will not absorb red light, so red light is reflected, and that will give us the color red as our object. Here, red is absorbed by our green object, so there's no wavelengths reflected, and our image is going to appear black. Same with blue. Blue absorbs red, and we're going to get black. So when we get to yellow, it's a little different. I'm a visual learner, so I'm going to put in here red and green makes yellow, and I'm going to go ahead and do magenta, red and blue, and then blue and green. So red hits my yellow object. It is part of the yellow light, so I know that the red will be reflected. Now, what about that green on my paper? Well, there's no green light hitting my paper. There's only red light, so I don't have to worry about that green for right now. So then our object appears red. Here, same thing. We have no blue light hitting, so then red light is reflected, and we get a red colored object. Here, our object is going to absorb the red, and it only reflects blue and green. So that means there's no wavelength being reflected, and we get black. Red hitting black, red is absorbed, no light is reflected, and we get black. For white light, it's all three flavors of light. So we have red, green, and blue. There's no green light hitting our white paper. There's no blue light hitting our white paper, only red. So therefore, red is reflected, and our paper is going to appear red. Okay, let's do the next one. Okay, so let's now do a secondary color. Let's choose magenta. Okay, so let's do our possibilities. Make them a little bigger. 1, 2, 3, 4, 5, 6, 7. Oh, ran out of room. Okay, so I'll try to get them more even. So I have room 3, 4, 5, 6, 7, 8. So we have red, green, blue, yellow. For me, I'm going to put in here that that's red and green, so remember. Magenta, I'm going to put in that that's red and blue. Cyan, green and blue. And then we have black, and we have white. So red, green, and blue. So magenta, as we know, is made up of red and blue. Here's where you need to show me that there are two lights hitting our red paper. So we have both red and blue hitting our red paper. Blue gets absorbed and red is reflected. So our color is red. Got red and blue. Our green paper only reflects green light, so nothing is reflected, and we get black. Red and blue. Red is absorbed, blue is reflected, and our object is blue. Red and blue. Red is the only one that gets reflected, blue gets absorbed. When we have magenta, we got red and blue. Both colors are being reflected. And we know that they add together, and the color we're going to see is magenta. Cyan, the blue gets reflected. It absorbs the red light, and we see blue. For black, it absorbs both colors, so nothing is reflected, and our object appears black. For white, both the red and the blue are reflected. There's no green light hitting our paper, so it doesn't matter if it's being reflected or absorbed. And we know they add together to make magenta. Okay, let's do one more thing. Okay, so let's now do one with an object. And let's just go ahead and do an object that is made up of secondary color. So let's do cyan water on a beach. That's that blue, nice blue-green color. So we have cyan is going to be our object. Okay, so all of these are going to be my object because we're going to use the same object. And me being a visual learner, I'm going to put that it can reflect both blue and green to help me remember. You don't have to do this, but for me it helps me. So we know cyan is our object, and now we want to put in, oh, I forgot. 1, 2, 3, 4, 5, 6, 7, 8. No, I guess I had it. Now we want to put on all the colors of light. So we start with a red light. So I have red hitting my cyan. Nothing gets reflected. And so we have black. We have a green light. Green's hitting. So green gets reflected. The blue doesn't get reflected because there's no blue light hitting it, and our object's going to be green. Then we have a blue light. Blue light is hitting our cyan object. Blue gets reflected, and our object appears blue. We have a yellow light, and we know that that's going to have both red light and green light. The red light gets absorbed. Green light is reflected. That gives our object as green. We have a magenta. And we know that that's made up of red and blue. The red gets absorbed. Blue is reflected, and that gives us a blue. Our object will appear blue. We have cyan. So we know that we have blue and green. Both will be reflected. We know that those add together and our object will appear cyan. Then we have a black light. For us, that just means there's no wavelengths being put out. So there's no incident angle. With no incident angle, there's no light, and our object's still going to appear black. Okay, for white light, we know that red's hitting it, blue and green. We know that our paper, or our object, let's see, what was it, water, will reflect blue and green and absorb the red. We know those add together to make cyan. So there you go. Hope this helps.